Hi, periods 2 and 3. Good morning. This is Miss G. It is Thursday, March 19th, and I hope you had a great day yesterday. Hope you got out and got a little sunshine. It was a pretty day. Hope you got some fresh air. So, hope you're ready to start our little topic today. We're still in section 5.1, doing some applications of differential equations. These are our little business applications. And seeing that I didn't have any questions from you from yesterday, I'm hoping that assignment went really well. Okay, so let's start. I have two types of problems today. One is finding a cost function given the marginal cost and fixed cost. So let's see, what is a fixed cost? A fixed cost is the cost that must be paid regardless of the number of units produced. For example, if you're renting a building, it doesn't matter how many things you produce, that rent is going to stay constant. It's a fixed cost. So now what we're going to try and do with our fixed cost is translate it into a point on our cost function. And the fixed cost is the cost that we have regardless of how many units. So really, it's the cost we have when we're producing 0 units. We produce 0 units, we still have that cost. So we can take whatever they give us for the fixed cost and make a point out of it by putting 0 for the x-coordinate and the fixed cost for the y-coordinate. And 0 is the number of units produced. Our marginal cost we talked about earlier this year, it's the cost per unit, or the additional cost of producing one more unit. So, and because it's a cost per unit, it's a rate, and because it's a rate, it's a derivative. So what they're going to do is give you the derivative, give you the fixed cost, and you have to come up with the original cost function. So here I'm doing example 300 on page 320, number 56. Determine the cost function given the following. The marginal cost is dc dt, because it's the rate of change of the cost with respect to x, the number of units produced. And so dc dt, the additional cost of producing one extra unit, is given as 1/50th x plus 10. So that's our rate of change, or our marginal cost. What else they're going to give us? The fixed cost. That's the cost, the fixed cost that doesn't change, so we assume that's the cost even when we're producing 0 units. So that cost in this problem is $1,000. That's 1,000. And so we can translate that into a point using 0 for the x-coordinate, 0 units, and 1,000 for the fixed cost, the y-coordinate. And that's going to help us solve for, well, I would say C, because in the other problems we did yesterday, we solved for C. The only reason we're not solving for C with this point is because we already have C standing for cost in this function, and we don't want to get that C confused with what would have been this C, so they changed this C to a K. A little confusing, I hope you get it, but this K here is like the plus C from yesterday. All right, so what are we going to do? We need to integrate dc dx to get back to the cost function, which is C. And we do it the same way we did yesterday. Here's our function. We multiply by dx. We get dc equals 1/50th x plus 10, that quantity dx. What are we going to do? Integrate both sides. When you integrate dc, you get c, because this is 1 dc. We're integrating 1 dc with respect to c, so we get c. The integral sign goes away, and we're good. Now we integrate this side with respect to x. So we add 1 to the exponent, we get x squared, and we divide 1/50th by the new exponent, which is 2. That's going to give us 1/50th divided by 2 is going to be 1/50th times 1/2, which will be 1/100, x squared. So there's our first term. Then we integrate 10 with respect to x, which we now know is just 10x. 10x. And then yesterday we put plus c, but because cost starts with a c, we don't want to get that c mixed up with this c, so we just changed this c to a k. All right, so now we have our general solution cost function. Now we're going to plug in our point from our fixed cost. So that means 0 is going in for X and 1,000 is going in for C, the cost. So 1,000 equals 1 over 100 times 0. Oops, look what I forgot. 0 squared. Really should have that there, sorry. Plus 10 times 0 plus our K. So we can see that this is going to be 0 and this is multiplied by 0, so we get 0 plus 0 plus K. So K turns out to be 1,000. So our cost function, C, is 1 over 100 x squared plus 10x plus 1,000. That's our K value. Okay, I hope you got that. I've got 2 problems for you to do like this in homework. And then one more sort of similar problem, finding a profit function given the marginal profit and the initial condition. So the marginal profit, again, is a rate of change. It's the rate of change of profit with respect to the number of units produced. Our initial condition is given as P of 5. That's the profit of producing 5 units is equal to $650. So they're giving us 1 point on our curve to help us find C. We're back to C. We can use C from yesterday because profit just has a P, so we're not going to get those confused. All right, so same process as yesterday, but in the context of a word problem. So dP dx is going to equals negative 40x plus 250. We're going to integrate that to get back to what? Our profit function, which is P. So first, we multiply by dx. So dP equals negative 40x plus 250 times dx. Now we're going to integrate both sides. We integrate dP, and we're going to integrate negative 40x plus 250 with respect to x. Integrating 1 dP gives us P. Then we do our little process. Add 1 to the exponent, we get x squared. Divide the current coefficient by the new exponent, negative 40 over 2. Plus, integrating our constant, we know it's just the constant times x, 250x, plus our good old C from yesterday. There we go. So, simplifying, we get P equals negative 20x squared plus 250x plus C. That's a general solution to this differential equation. Now, that is our profit function, which will tell us what our profit will be based on how many units we produce. But we know a little bit more about the production because we have a point on this curve. So we're going to use that point to help us find this C. So now we're going to plug 650 in for our P value. It's like our Y. And we're going to plug 5 in for our X in our profit function. So we do that right here. And of course we have our plus C. We work this out. We get 650 equals negative 20 times 25 plus 5 times 250, which is 1,250, plus C, which gives us 650 is equal to negative 500 plus 1,250 C plus C. Oops. And then we end up with, I'm sure you can follow this, then we get C is negative 100. So our profit function is negative 20x squared plus 250x plus C, but now that plus C is minus 100. That means if we want to know what our profit's going to be based on this equation, we just have to put in the number of units produced, which is our X, and calculate this out, and it will give us our profit. Okay, I hope that made sense to you. This is in the book, and you'll see that the problems are on page 320. Yes. So here is the assignment. Section 5.1, page 320, numbers 55 and 57, 61 and 63. I wish you good luck with that. If you have any questions, just email me and I'll explain them for you or do them on my next video. Meanwhile, have a great day. Take care.